Hello, it's me, and in an effort to continue my viewer request series, I've had a couple of requests to continue my Rubik's 180 scramble slash solution using the 5-layer. So as you recall, I've done a 3-layer version, 4-layer version, did a supercube version of it, as well as some mods of it. So I had some requests to just continue on with that, so that's what I'm going to do. Now this is a 180-degree scramble and a 180-degree solve. And it's an interesting thing to do because to those who might not be able to afford a lot of the cuboids out there, or a lot of the bricks in particular, the solve strategy with those is you get it to a point where everything is within 180 degrees from each other by doing cuboid strategies, and then solve it using the algorithms that we're going to talk about. Now if you wanted to review that, you can, because the algorithms are the same. Now as an example, we did the 4-layer, and I'm just going to use this in honor of all my Canadian friends here as a 3x3 version. But there's one algorithm that we used in order to swap things by just doing 180-degree turns. If I wanted to say swap these two here, then that algorithm was of course 2U, 2R, 2F, 2U, then just one 2U, then 2F, 2R, 2U, and 2F. And you can see it swaps these two. But there's a price to pay. And that price was the fact that it actually swapped these two as well. And that has to do, of course, with the law of cubes. The law of cubes states that I can't have an odd number swaps, I have to have an even number swap. So the price I paid of swapping these two was swapping these two, but that wasn't a huge problem. Because there's no parity in this puzzle, I could actually set things up to where the last move would be able to do that. I can't have a last move where there's just two. 2U, 2R, 2F. To U, 2F, 2R, 2U, 2F. Okay, now compare that to when we did that same strategy with the 4-layer version. It's the same algorithm except that middle 2U was also joined by another 2U. Now this is an interesting situation because here there's no problems using these centers, these edges, and swapping these two without swapping these two. And the reason is that although we're looking at these as reduced edges, they're really not. So which means while I couldn't just swap these two edges without swapping these two, because I needed a even number of swaps, I can just swap these two because this is actually 1, 2, 3, 4 pieces. So it's like swapping these two and swapping these two. So I don't need to swap these. So that variation of the algorithm using the 4-layer, the 4x4, is the same thing, start off the same way, 2U, 2R, 2F, then once again we do another 2U, and then another 2U above that, 2U, then finish it up with 2F, 2R, 2U. We cleanly swap these two and we don't affect these. So in many ways that was kind of easier. Now we had some variations of that with supercube versions of it. I'm not going to go into that now because it's not going to have relevance with these cases here. But in that way I didn't have to worry about doing right angle swapping. So it was all very simple, very straightforward. 2F, 2R, 2U. So how do we translate this in the 5-layer version? Well, the good news is the algorithms are the same, and I'll actually have a choice because I can do the even layer version of it if it's just these two that are out that need swapping, or the odd layer version if I just wanted to swap these two or swap these en masse. So there's a process of reduction. Now, here's what I would recommend. Here's what I would suggest. To those who requested the tutorial, this is for you. To those who have not, my suggestion, if you've not tried it before, pause the video now and go ahead and try it. See how you do it, see how you fare. You can use the previous tutorials for the Rubik's 180 to help guide you, but go ahead and try it and then see if my method is the same or if you run into trouble. So pause now. Did you do it? Well, if not, we'll go through that. So just by those algorithms, we should be able to get through this. The question is just strategy. So just kind of go through 180-degree scrambles. And again, I'm really recreating the last steps of a brick cuboid. Now, even as I'm scrambling this, although it seems random, the fact of the matter is, and after having done these solves for some time, there's a pattern to what I'm doing. Not a pattern that I'm attempting, and not a pattern that I'm trying to make happen, but a pattern nonetheless because I know that there's a symmetry to how these are being scrambled. I know that there is no actual parity with this, so I'm not breaking any laws of cubes. Every turn that I make means that there's a very consistent pattern that's going to be happening with the scrambled state, which makes the solved state easier to navigate through. So I'm going to keep doing this and see what we got. Abracadabra. Okay, that probably doesn't look too much different than before. So here it is. A fully 180-degree scrambled puzzle. I'm going to start off with centers. So here's the key. When looking at a center, a 5-layer center, this almost looks like a 3x3 in terms of its organization. These are all center pieces, so to speak, but we have a middle center, we have edge centers, and we have corner centers. Just like these are all edge pieces, these are corner pieces. So that's how I'm going to identify these. These 4 are going to be corner centers, edge centers, and middle center over here. So to put this in, what I'm really trying to do is I'm going to try to create appropriate 1x3 bars. An appropriate 1x3 bar is either everything is all in of the same color, or at least the 2 corner centers are in. Because if two corner centers are in, I can find a homologous corner center on the other side, and then from there I can do the placement parity algorithms that swap the 2. Just as we saw with these 2, as we saw with this, and I don't know what this guy's doing here. Just try to get a piece of the action, I guess. So the first challenge is to try to set that up as much as possible. Well, what I see here is I see these 4. If only I could put 2 oranges here, then I can maybe have that configuration. So I'm just going to find a situation like this. I see this is all in over here. And I need to do it to where there's 2 that I'm moving in. So I see a bar over here. I'm just going to move it to this side. Now, there's not a huge degree of, there's no algorithms that you really need to know. And even the strategy is pretty simple. If you just mess around with it, you're going to get a configuration that looks something like this. I've got these 2 in over here and these 2. So these are symmetric. Now, if I wanted to swap centers, if I wanted to swap these pieces, I could swap it. I can do a middle swap, or I can do a odd layer swap of just swapping these 2, or an even one swapping these 4. It's easier to do the even layer one because you don't cause disruption at right angles. So what I'm going to do is I'm going to put the yellow edge to the yellow side and the red edge to the red side, because now all I have to do is just swap these corner center pieces. The algorithm is the same, but my F move has to encompass these sides here. So this is F move, and this is going to be one U move, and this is the other U move over here. So it'll be pretty apparent. I'll have the algorithms that show capital or small, but you'll see what I mean. So the algorithm is, once again, starting here. Where you have your placement parity, placement issues, is you start with your first U is just beneath the first placement issue. Just like if it was here, you'd start off here, and then this would be the next one. So what do I mean by that? So go 2U, 2R, and remember the F is here, 2F, then 2U, 2U, 2F, 2R, 2U, and we got it. Simple as that. So now let's apply that to other centers. How about these guys? Well, let's look around. We see that these 2 corner center pieces are in, and it must correlate with, well, we've got a bunch. These 2 are in, these 2 are in. Let's try to make it to where blues are going to go where blues are, green are going to go where greens are. So these are here as well. So I'm going to double turn this over here so I can move these greens to here, being replaced by these blues. So 2U, 2R, 2F, 2U, 2U, 2F, 2R, 2U. In and in. So you can see a pattern here now. All of my corner center pieces are in, and all I have to do is start flipping these guys. Well, again, I could just do an odd layer flip with these, which would cause havoc at right angles. But so I'm not going to do that. It really wouldn't matter because it'll cause havoc on the outside here. So let's stick with the even layer. Let's go ahead and double turn this over here, so that now we're going to just move these 2. So we're going to swap these guys. That way we don't run into any trouble at right angles. Not that we care yet, but yeah, good to know. 2U, 2R, 2F, 2U, 2U, to F, to R, to U. So that's good, and we're left with this, and we're left with this. And now what we need to do is we need to move potentially these, just swap these two so that this blue can be with the blue. But how are we going to do that and maintain this over here? Well, here's my suggestion. My suggestion when you run into this is don't swap these middles. Because you're going to cause issues at right angles. It doesn't really matter, but it's just better. Go ahead and put in all the 1x3 bars. So we're going to take these two blues and swap it with here. So it's not going to be in the right center, but at least we'll have our 1x3 bars. When you come into this situation, and you already have, you know, two centers here. So to U, to R, to F, to U, to U, to F, to R, to U. So we have this situation. Now I have these 1x3 bars that have to go like this, but we don't want to mess this one up either. Now this you can kind of intuitively, I think, figure out how to do this, but basically what I want is I want 1x3 bars to be out on all sides so that when I double turn it, I can move it all in. So I have to have it out here as well. I have to swap these two. So here's a general way that you can do that, is why not just do a 2R, some sort of a move that puts these out, but does not solve this yet. So here's what I mean. What if I were to double turn it like this, move this green to here and this green to here? If I do that, this will still be out. This will still be out over here, and I'll have two greens. If this green is over here, this will be in and one will be out. But we'll have one out here and one out here. So I can coordinate those. So I'm going to just swap one color with the same, just like this. I still have two in, one out. Now two in, one out, two in, one out, and as you can see. So what I'm going to do then is just coordinate it together, double turn. So now all of these can be moved in conjunction with each other, bang, and we're good. So these are all in. I'm going to apply those same concepts to this center. So let's take a look at what we have. So we're going to try to move things as much as possible. What I see here is I see two corners that are in here, two corner centerpieces here, and two corner centerpieces here as well. It would be nice if I can move one to this side. So I'm just going to do that in the same method that we were talking about. So it doesn't matter what else is happening on this side, but I'm going to go 2R over here to move it to this side. And if I'm a little skittish about this being out, that's okay. I can just do 2R over here and move it like this. So this is all back. All that really mattered to me is that I have two corners here and two corners here that I'm going to swap. So let's see what happens if we do that. To U, to R, to F, to U, to U, to F, to R, to U. Now this is just one strategy. You can use whatever strategy that you want. So you can see that we have 1x2 bars pretty much everywhere. What I'm going to do is I'm just going to start putting these yellows back into here. So I'm just going to double turn this over here. So white's where white's supposed to go, yellow's where yellow's supposed to go, and now I want to move these guys. So I'm just going to move this in conjunction with these so I can easily turn this over here. Now we just have this familiar situation. Two corners, swap them so that the edge centerpieces are fine. Then we'll have our 1x3 bars and then get it back the same way. To U, to R, to F, to U, to U, to F, to R, to U. So notice we've done 0 new algorithms. It's actually just the even layer switching algorithms that we were doing. The rest is all positioning. Now I have to swap these two. So once again, same strategy. I'll turn this to where yellow will swap with a yellow, which will put everything in coordination with each other. Double turn this over here. So these are all coordinated, as you can see. Double turn and bang. All of our centers have now been reduced. Okay, edge reduction. Here's the good news. No new algorithms. Here's the bad news. Well, by doing this, it's going to offset the center a little bit, but we know how to get them back. If, say, this ends up flip-flopped with over here, we know how to get them back. So what we're going to do is the same thing. We'll start off with these. Now the key here is you're going to have a couple potential situations. One of which is you're going to have the corners in. the corners in like this, or you're going to have a situation where none of the corners are in. So starting off over here, if the corners are in, you have the possibility of every corner being in. And that's usually what's going to happen. Every corner is in. So let's take a look here. Where's the other green and yellow? It's right over here. So I'm going to put this next to where it's supposed to be, like so. And then I'm going to do the placement parity algorithm to take this and transport it right next to here. Now these, the green and white, is going to end up here, not where it's supposed to be, but that's okay. It's not going to offset anything else. It's not going to create right angle problems, placement parities. At least I'll have one solid bar in. So find one, line it up, and do the, now this time the U is here and the F is going to be here this time. That's going to be 2U, 2R, 2F, 2U, 2U, 2F, 2R, 2U, and that will do what I call a clean swap. So this is fine. Now I just look to see what else needs to happen. This is the blue and white. Here's the blue and white. These two can swap over here. This will swap to here and be useless with this guy, but we have a plan for it over here. So once again, 2U, 2R, 2F, 2U, 2U, 2F, 2R, 2U. Clean swap over here. All we have left is this. Blue and yellow to here, green and white to here. Once again, 2U, 2R, 2F, 2U, 2U, and 2F, 2R, 2U, and you got it. Okay, this represents the simplest scenario that you might see. So let's get something a little more complicated. Now that we've done this plane over here, let's hit these guys. So here you can see that there are no corners that are actually in. No corners that are in. What you're going to look for is you're going to look for something like this, where you have two colors that are in. Now what you're going to have to do is, unfortunately, these edges are not coordinated with the center. If they were coordinated, you would have had two edges in, but you don't. So this is where things are going to get a little bit messy. And again, you can think of other strategies too. So let's look for the other red and blue. The other red and blue is over here. I need to get it over to here. So if it's just below it, I'm going to put it back over here. And now is when I have to kind of mess up my center reduction a little bit and go like this. Okay. Once I've done that, I have, you can see that both my corners in, actually this is all fine here, but all the rest corners have to be in. How do I know that they're in? Well, because of the law of cubes. I know from the consistency of the scramble of this, it has to be that way because there's no parity involved in this. I'm not going to have this corner in and nothing else. So in, and in. Now by in, I mean that they're the same. The centers may be different. The center portion of the edges may be different, but that's okay. So what do I do from here? Now understand what I had to do in that case is I had to mess the centers up. Ignore that for now. Now that I have that, we're going to proceed the same way we did last time. So where's the other red and green? It's right over here. So I'm going to swap these guys. And it turns out that I'm going to have both of these in. So even layer swap, 2U, 2R, 2F, 2U, 2U, 2F, 2R, 2U. So we're good. Good over here, good over here. Scary, scary. So you see that these are all in. If they weren't, you just keep going around until you do that. So now what? Now what do we do? How do we get these guys back? Well, here's an interesting property about what just happened. When I put these in, what I'm actually going to be doing is I'm going to be holding it like this and doing a parity placement algorithm where this whole thing is considered to be an edge. Before, this was the edge and these were the corners. Now this whole thing is an edge and this is a corner. So I'm simply going to turn this to where we're going to be placing that in. So I'm going to turn this over here. And what I'm going to be doing is we're going to be swapping these two and getting it back. Now, this is going to be an odd layered version. For an odd layered version, I know what's going to happen is I'm going to actually create placement parity at right angles, which is going to be these guys. So it's not going to be this whole edge that's swapping. It's going to be just these edges that are swapping over here. But don't worry about that because these two are going to be swapping and so are these. So just like in the last step of the 3x3 180, By doing this, we can actually consistently get it back in. So what I would do is hold it here and go ahead and do the odd layered swapping algorithm here. So to U, to R, to F, this is going to be the F, to F, then to U, then to F, to R, to U, and to F. Okay, this is going to be back, this is going to be fine, and we'll see that, yeah, we created parity. So we actually caused disruption of this guy over here, these edges that we already put in. But have no fear, because what we're going to do now immediately is we're going to turn it here counterclockwise so that it can match up with this. We'll actually just turn it over here. Okay, so now I'm going to do the same thing here. But now notice these two got misplaced. I'm actually going to use this next move to swap it back again. So what I'm going to do is I'm going to turn this down here, so this is going to line up with this. Now I want these two to be opposite each other, just like they were before. So this is down, I'm just going to turn this over here so that these two are opposite each other. So now what's going to happen is these two will swap back, and I'm going to use the law of the cubes to my advantage because what I swapped out is now going to swap back again. So it'll be fine. So watch what happens. To U, to R, to F, to U, to F, to R, to U, to F, and as promised, what we swapped out is now perfectly fine. So we are good. So we have the last set of edges to go over here. So just for practice, let's do that again. So understand, this used to be here and here. These are swapped. It's going to consistently work like that. So once again over here, as you can see, we have edges that are not in. None of these edge portions of the center are in. So let's find two that are the same next to each other. Red and white, find the other red and white, which is here. This has to move to here, so same thing. Move it behind it, and we're going to throw off these centers and move this over here. Now all the edges are in. In and solid, in and solid, not in, not in. So this one is simpler still. We're just going to go ahead and do our parity swap, our placement parity swap, to get these in here, and it'll reduce all of our edges. So starting from here, to U, to R, to F, to U, to U, that was a close one, then to F, to R, to U. Okay, so all of our edges are now reduced. Now we got to get out of this. Well, once again, just simply move it to the left and to the right. I'm just going to turn this over here. What I'm going to do is swap these two, do a clean swap of these two, which will create placement parity over here. That's going to be to U, to R, to F, to U, then to F, to R, to U, and to F. So that did put this back, but the price to pay was placement parity over here. Don't worry about that. Just now turn it now to where these guys are going to be swapped. All I have to do is, bearing in mind I want to coordinate it with these two edges here so I can swap these back at the same time. So double turn this over here so that this and this are lined up. I've got this down here. Let's take this wandering edge piece, put it here, and now one more application of this algorithm will not only bring my centers back, but fix the messed up reduction over here. And that's going to be, once again, starting with the 2U over here. Remember, we're swapping these two as an odd layer swap. To U, to R, to F, don't mess up on that, to F, to U, then to F, to R, to U, to F, and as promised, it's all in. So now we have a completely reduced 5x5. All the centers and edges are reduced. Now we just solve this the same way that we did with a 3-layer version, the Rubik's 180 3x3. So just to review that, the first thing that we do is we put corners in, because now all these edges are going to be swapped again. Putting in the corners is fairly easy. So let's say I look over here and we're going to do green. Well, this corner is correct. Orange, yellow, and green. Where's the green, orange, and red? right over here. So I'm just going to double turn it, and you're always going to find a way to double turn these things and double turn it over here. So this is in, the other greens have to be down here, and they have to be already lined up. How do I know that? Well, say it with me, because of the law of the cube. So I'm just going to line it up to where it's supposed to be, put it into here, so we have all the corners in, and on the bottom all the corners will be in as well. Sometimes they have to double turn it here. You will not find issues with this, because there's not going to be parity with this puzzle. If there was, then there's the potential of having things being messed up. Maybe corners were in here, but not here, but they were in here. We saw that with floppy parities and how to get out of that, but you're not going to find that with this. So now with all the corners in, it's just a matter of doing edge swapping exactly the same way. So we're going to look, and this is kind of the fun part of it, because we're going to look for ways to solve two at the same time. So let's take a look at what we have and what we can do. What I'm seeing here is that this belongs over here. So I'm about to put this over to here, and this will come over to here. When I do that, these two are going to be swapped out, which is fine. As a matter of fact, maybe I should look at it like this, where I have these two whites, and I can cleanly swap these two. So that'll be good. This doesn't belong here. This does belong over here. So this red and blue might need to swap with this. So these two can swap. If I wanted to make these two swap, I'm just going to take this and deposit it over here. That way these two will swap, and then this will swap with this. But if this is here, then it'll be like swapping these two. If that didn't make sense, stop tape, rewind it, and see what I said. But what I'm going to do then is take this, do it 2L. Then I'm going to bring this all the way down to here so that now it's opposite here. Then do it 2L to bring it back. So now these two are going to swap, and these two are going to swap. 2U, 2R, 2F, 2U, 2F, 2R, 2U, and 2F. So these two swapped. These two also swapped, which is what I wanted. So now I just need to move this back over to here. So I'm just going to double turn this down here, move this in, and then move this up. This is all positioning. So the end result is these two swapped and these two swapped. Okay, let's see what else we have. This white needs to come over to here, maybe swapping with this white. So what I'm going to do is I'm going to do a clean swap where this will come to be here where it needs to be. This is going to come over here where it's not where it needs to be, but that's okay for now. So 2U, 2R, 2F, 2U, 2F, 2R, 2U, 2F. So this is where it needs to be now, leaving me with this and this having to swap and these two having to swap. You're always going to end up with a situation like this because, like I say, it is impossible to have a situation where only two need to be swapped. So what I'm going to do is I'm just going to take this orange and yellow, and it has to come over to here. And this red and white have to come over here. So I'm just going to double turn this like so. These two will swap, and then these two will swap. Now remember, they have to swap because when I turn it back, the corners are going to be correct over here. I'm just double turning it over here. So swap, swap, and then we'll turn it back, and then we got a ball game. So 2U, 2R, 2F, 2U, 2F, 2R, 2U, 2F as promised. They swapped, and now I just turn this back, and you got it. So that is your Rubik's 180 5x5 cube solve. So hopefully that answered the questions from those that had problems with this. My question now and my challenge is, dare you try this with a 5x5 supercube? Because I'll tell you, this was easy compared to that. So tell me what you think. More of your requests coming up. Thanks for watching.